Unnecessarily 5-10 minutes we are just wasting. Okay, I'll start. Okay, good afternoon, every one of you.
Good afternoon, sir.
Hi, good afternoon. Okay, we will solve one more problem based on this one. Okay. Okay, I hope everybody understood the previous problem. Shall I move to the next problem? Once again,
Yes, sir.
Okay. Yeah, okay. Okay, this is problem. This is also based on the single stage problem, or we can say general problem in the single stage process. So a slurry of flaked soya beans weighing total of 100 kg. So a slurry is there in which a flaked soya beans, okay, mashed soya beans are there. So 100 kg, total weight is 100 kg, contains 75 kg of inert solids. Inert solids, according to our notation scheme, it is B. Then 25 kg of solution. According to our notation scheme, solution means A plus C. So A plus C is 25 kg and this B is 75 kg in the feed. Then with 10 percentage. So among this 25 kg, so this okay and solids okay 10 percentage which 10 percentage weight percentage oil and 90 weight percentage solvent hexane was there. So among this 25 kg of solution, so this C is 10 percentage, 10 weight percentage of this 25 into 0.1 is the weight of oil inside the feed, and 0.9 into 25 kgs, which is the weight of solvent A in the feed. Then the slurry is contacted with 100 kg of pure hexane. So pure hexane or fresh solvent, okay, both are same, hexane or fresh or pure, whenever they refer, that means only the single A is there in the solvent stream, whereas B and C are in a single stage. Okay, in a single stage operation, this is also important, so that the value of N, so value of N in the for the outlet underflow is 1.5. So in the inert solid stream, okay, in the inert solid stream, the value of N is 1.5 kg of insolubles per kg of solution retained, means kg B by kg A plus C. So same according to our notation. Then can the amount and composition of the overflow and underflow leaving the stage. So now what does that mean? We will see in the symbolic way. So this one, every time when you encounter this type of leaching problem, just one circuit and list out what the 4 streams which are there, 2 input streams, 2 output streams. So now what happens in the feed stream? This stream just we have to label something with. So this is feed stream. Then this is pure solid stream. Then the leaving stream is this is solution stream or raffinate stream. Then this is extract stream, or we can say inert solid stream. Okay, this is raffinate. We can say now from the given data, a slurry of flaked soya beans weighing total of 100 kg. So total of 100 kg is the soya beans, that weight of that soya bean. So out of that 75 kg is inert. So B is equal to 75 kg, and solution according to our notation F is equal to A plus C is equal to 25 kg. Among that, with 10 weight percentage oil. So our oil notation scheme is C, which is solute, is nothing but 10 weight 25. And 90 weight percentage is this one, A. So 90 weight percentage is a pure hexane is there. So 0.9 into 25. So this one is the data which has been given, and in the solvent stream. So the slurry is contacted with 100 kg of pure hexane in a single stage. So it is saying it is a pure hexane, meaning hexane or a solvent we are denoting with A. A is equal to 100 kg. When they are saying it is a pure means pure, or we will say fresh solvent, like this. So A is equal to something, then B is equal to 0, and also C is equal to 0. And once again, they have not provided the output data here. So we have to estimate that output data. In the output data, one single clue they have provided in a single stage, so that the value of S for that underflow is 1.5. So this stream is also known as underflow, and this stream is also known as clear solution or overflow. This is, so these streams are there. In underflow, they are saying n value is 1.5 kg B, insoluble means B, and kg solution means kg A plus C. This is the given data here. So using this given data, we have to estimate what are the unknown parameters. Now you have to list out this one: A is equal to what, B is equal to what, C is equal to what. For the convenience, every time you just list out this one. The problem, whether in the problem they have given or not, some data is missing or not, to identify that one, we have to list this one. So from the material balance, we already know that. Okay, so once again, I accidentally close this one more. Yeah, okay. This was the given data. Now from this data, we have to estimate what are the unknown parameters. First, from the material balance of the single stage, we already know this one. So single stage, two inputs are there. Input is equal to output. So F plus R naught is equal to E1 plus R1. This is the overall material balance, which is already equal to M. This we have to keep. Then solute balance is, you have to remember this equation. I am just deriving directly. I am deriving without any notation scheme or nothing. So this is F into YF plus R naught into X naught is equal to E1 into Y1 plus R1 into X1 is equal to YM1 into M1. These two equations you have to keep in hand. So now we already have this data. F is equal to something they have given. F is equal to 25 kg plus R naught is equal to some 100 they have given, if I am correct. So 25 plus 100 is equal to, we can equate this one. So these two are unknown parameters. So this we can make it M1. So M1 is equal to 125 kg. This one. Then the next unknown from this one is y1, ym1 we can estimate. How can we estimate ym1? By equating this equations, because we don't know this equation. This parameters we not at all, no data has been given for that one. So f we already know, f is equal to 25 into what about yf. So this 0.1 into 25 how much? 0.1 into
2.5.
2.5.
2.5, sir.
Okay, then yeah. 2.5, and this one is zero point 0.9 into 25 is
22.5.
22.5. Okay. Now we can estimate in this way, or otherwise we can say directly the YF is zero point 0.1 directly we can say. So YF we can estimate 0.1 this is. So YF is equal to 0.1. Otherwise you can just verify that YF is nothing but C by A plus C. So C is 2.5, A plus C is 25. Same thing you'll get. Then what is R naught? R naught is something 100. Okay. R naught is 100. Then what about X naught? X naught will be
0.
obviously
0.
0 because it's a pure solvent. They are already given that one. So it is 0 is equal to ym1 into m1 already we estimated from the initial this one. So this one we can write. So the value of
Divided.
ym1 is equal to divided by
Yes, sir. FYF plus R naught X naught by M1.
this one only, na?
Yes, sir.
Yeah.
0.02.
0.0. This one. Now we have the all the handy parameters we already have. But the shortcut method is now we don't have to grow any graph or something because we don't have any data. Okay, if we want, they want us to draw a graph or estimate the number of plates or number of stages. They have to provide some equilibrium data. So here there's no point in giving the equilibrium data. Now using the material balance equations only we can find out. So how can we find out that
Yes,
one?
sir.
Initially, if you say initially if you
B is
can
equal to
see this nf, nf means it is b by a plus c into what has to be multiplied so that it will get only b. So you have a plus c. So this a plus c, this a plus c can be cancelled out, only left out is b. So b is equal to nf into f. As soon as it will reach some equilibrium stage, what happens? This is always nm into m1 that has to reach, just they are equal. So this will be equal to this one. So in this, how many parameters we already know this one? nf. Did we know this nf?
yes, sir.
nf is how much? B
3.
by a plus c. So that is 3. Okay. Have we calculated that one? T.
Sir, other than that, we can use this method, no, sir.
Which method?
Because the solids are inert solids. In the feed, solid is 75 kgs. So in the inert solids also, B is equal to 75 kgs.
Yeah.
He gave n value, no, sir. N is equals to B by A plus C in inert solids.
Yes.
N is
Yes.
equals
Yes.
to 1.5 and
Yes.
B is equals to 75 kgs. A plus C is equal to 75 divided by 1.5, 50.
1.5.
We will get
Yes. Yes.
E1
Yes.
is equals
Yes.
to 50 kgs. With
Oh,
E1 we can
yeah.
calculate
That is also right. That is also,
R1 is
yes.
equals to
That
M1
is also
minus
right.
E1.
E1. Yes. Yes. That is also right. Okay.
Yes,
You can
R1 is
calculate
equals to
using that
75
method
kgs.
also. Yeah.
And
So
then we
this
can
the
calculate the other.
somewhat procedural method. If you understand material balance, that what you are saying is correct. So somebody will not catch that one directly. Okay, then this is NF. So inside this field is 75 divided by the solution itself is somewhat 25 kgs. So 75 by 25 into F already given, this is 25 is equal to NM1. What is NM1? Then already this M1 we already estimated. M1 is equal to 125. This is 125. So this you can cancel out. Then NM1 is equal to 75. How much it is? 75, 75 into 75 is 0.56 or 0.6 maybe. Uh, yeah. 0.6. This is correct. 0.6. Is it correct? 0.6? 75. Ravi?
Yes, sir.
Sir.
Okay. Then we already know this equation. E1 is equal to B by N1. So how it is E1 is equal to B by N1? So B is B, then N1 means B by A plus C. So B will be cancelled and it will be going upside. The same previous problem we have done this one. So E1 is equal to, from this one we can estimate what is the B value in the extract stream. B is equal to E1 into N1. No, E1 is equal to B by N1. So B we already know. So B is inerts only. So E1 is equal to B is equal to something they have given 75 kg.
Yes,
Yeah,
sir.
75 divided by 1.5 or 1.3 something there.
1.5.
1.5. So 75 by 1.5 is equal to
50.
50 kg. Yeah. 50 kg. Then from the initial, this one we can calculate, what is our R1 value or raffinate E1 is R1 is equal to M1, we know that one. Then E1 is equal to 50 plus R1 is equal to M1 is equal to 125. So therefore R1 is equal to 125 minus 50. So therefore, we can say R1 is equal to 125 minus 50 is equal to 75
75.
kg. You will get. Yes. Using the component balance, or we can say solute balance, F into YF plus R naught into X naught is E1 into Y1 plus R1 into X1. Using this equation, we can define this one 25 and YF is equal to 0.1 plus R naught is equal to 100 into 0 is equal to even something they have given even 50 into Y1 plus R1 is 75 into, so this is around 25 into 0.1 is 2.5. 50 y1 plus 75 x1 is equal to 2.5. So there are two unknowns are there, y1 and y2. So the degrees of freedom is greater than 1. Or we cannot solve this equation. So there are two unknowns, only one equation is there. So we cannot estimate the composition of these two streams, but we can estimate the weight of this two streams. So until now we can stop this one. But in the problem, if you can notice that one, they have asked us to calculate both. Calculate the
I
amounts.
think we can
Amounts means
estimate,
this
sir.
one. How?
Y1 is there, no, sir. Y1 is equals to C by A plus C. We know A plus C is equals to 50 kgs, no, sir. And X1 also C by A plus C.
Okay, one is equal to C by A plus C.
We can calculate C from that, no, sir. value
How
of
we
C.
can calculate from this one? Solution we don't know, na? A plus B here we don't know. So
Yes,
we
sir.
don't have a clue that some B may be here, some B may be here. We
Yes,
don't
sir.
have a clue.
Yes,
They
sir.
have not given that all the units are giving into one stream only. So we don't have a clue. Until
Yes,
unless
sir.
they provided some clue or they cancel out one stream means then only we can estimate. The clearly understood from this equation, there is two unknowns, only one equation is there. So we
Yes, sir.
cannot solve this equation. From this we can stop this one. This is single stage concerning about the single stage operation. Once again quickly I will try to summarize this one. If you understand this single stage, so multi-stage cross current and multi-stage counter current will be very easy. If you didn't understand this one, then it is very hard to going on. Okay, then single stage. Okay, in the single stage the notation scheme is very important. If you understand notation scheme, then finding out is very easy. Whenever some inert solids or insoluble solids somebody is saying means the notation which has to come up you come in your mind is B. Whenever pure solvent they are saying, the notation which has to come up your mind is this A. Whenever soluble solute or something oil something they are saying means you have to come up with C. So these notation schemes are very important. Okay, if you have this notation scheme in your handy, then you can apply this formula easily. Otherwise, these formulas are not valid. When you define your own notation scheme, it is up to you. You can define that one. So this leaching operation, inside this leaching operations, there will be a four streams. So out of these four streams, two are input streams and two are output streams. So input streams, in order to omit the existence of this B, so all the parameters are defined in such a way that we have to make them free from B, free from in the inner solid, because its quantity is going to remain throughout the operation same. Throughout the operation, it is going to remain same because they are inerts. They are not at all participating in the solution reaction or solubilizing reaction, solubilizing process. They are not at all participating. So actually feed needs to be A plus B plus C. But in order to omit that B, we are defining only our feed as a solution. Solution means we already know solute plus solvent is gives rise to solution. So here the solute is C or oil or in the soluble matter, whatever is there, that will be C and solvent is A. Here B. Then the mole fraction on a B-free basis of solute is defined as C by A plus C. Then for the accountability of this B or inert solids, we have taken the notation NF, N subscript capital F is equal to B by A plus C. Similarly, in the same fashion, for every stream, we have defined the solute and this solvent and extract and raffinate stream in kgs or in a quantities, and next notation scheme are for mole fractions or mass fraction or mass ratios we have defined. The same formula, if you remember one mole fraction, so the same formula is applicable and same formula is applicable here, but the quantities of CAB, everything is going to differ in each stream. That you have to remember that one. But the notation scheme is same. CACB, everywhere in every stream A, B, C will be coming into existence. But you have to note that in every stream their quantities will be different. So A are different in their quantities only, not with the notations. So that's a single stage problem. So in order to estimate graphically some of the missing parameters, usually now whatever we solved the second problem is direct material balance problem. From their material balance problem, we directly can solve. In the earlier problem, the first problem, they have given us a data. So x versus y data, and also they provided n is a function of y as a function of y. They have provided a data. Then we have to draw this type of graph, and we have to estimate graphically what is R1 and what is E1. So how to estimate that one? First, we have to draw n versus xy graph. Then next we have to draw a distribution curve or equilibrium curve. We can say x versus y. Then after drawing these two graphs, first point is you have to x versus y, we after drawing this one, you have to draw this diagonal line and graph. Obviously, it is coming to exist. Then in n versus y, they are coming. If x is not at all a function of n, then this will be your n versus x. If x is a function of n, then that will also coming some curve. But usually for your limited syllabus, it will be same. N versus x will be this x axis only. Largely, it will be x axis only. They will not make much complicated. The problem will be. Then after drawing this one, first step you have to do is locate this point F. Point F, YF on the x-axis, then NF on the y-axis. Then the next point is locate R0. Then the coordinates of this R0 is x0 on the x-axis and N0 on the y-axis. Then this will come here. Join R0 TF line with a straight line. Then after joining this, next point estimation is M1 or M we can say. So the coordinates for this M is YM1 and NM1. After locating this, usually this M1 or M1 will be falling in this straight line only. So every time you have to remember, if that M1 is falling somewhere else means your parameters, this YM1 and NM1 is somewhat, they are different, we can say. You have wrongly estimated that one. That is going to be that is wrong one, you can say that one. Then after locating this point, the third point M1, you have to draw a tie line, we can say. This tie line you have to draw. How to draw the tie line? The clue is the best trial and error method we have to go. Here the clue is first you have to assume x value, because this n versus x is there here. So xr is the mole fraction in the raffinate phase. We are denoting with x only. So we have to just guess some x value. Then that point has to be projected up to the equilibrium curve or a distribution curve. Then in a horizontal right line, you have to take that line. Then after that, we have to once again take the same line, after touching the diagonal, we have to take down once again up to this n versus y. Then if the nodal points, the initial points which we have guessed, and the final point has been reached at n versus y, if that point is just falling on this m1 or m, then your tie line guess is very much correct. Then that is true x value. Then if that is not correct, then you have a clue that you have to move in the um, right direction, or you can move in the left direction. Once you evaluated, once you guess 2 points, you come to know where this exact point, true point has been located. So after locating this point, if your tri line is going to be correct, then you have to estimate the values of y1 and x1. So how to estimate that one? So this point is y1 if this is your true tie line. So this one projected on the y-axis, this is y1, and this one projected until the x-axis, this will be x1. So these are nothing but compositions of solute in the extract phase, and this x1 is composition of solute in the raffinate phase. So since one stage is completed, then we can go for the multi-stage operation. In the multi-stage operation, there are two types of operation is possible. One is a cross current and next one is the counter current operation. So what are those? We can see here. So this one is a multi-stage cross current operation. Okay. Okay, I am assuming you already understood the single stage operation. I'm not going to ask you one more time. If you have any doubt, you can stop me anywhere. Okay. Then this one is multi-stage cross current operation. So cross current operation is just very simple. This one compared to the counter current operation, cross current operation is very simple and very easy approach. Why? Because only one stream is going to add to the next stream. So this stage 2 is dependent on the output of the first stream. But in the counter current, what happens? Raffinate, both raffinate and this extract streams, both are going to affect the any single stage, and each stage they are going to affect. But here in each stage, only the previous extract stage is going to affect. But the effect of this raffinate will be unilateral. We can say it is only unidirection. So it is varying for this stage only, or not raffinate. One raffinate is varying for this stage, and next raffinate is freshly adding, or next solvent stream is freshly adding for each stage. But that is not the case with counter current operation. both the streams, both the raffinate stream as well as extract stream going to affect that one. Because of that one, because of that reason, this is cross current is very much easy. So cross current usually will looks like this one. When you conduct a material balance on each stage, these formulas you can obtain. Consider there are NP number of stages out there. NP means maximum number of stages. NP number of stages are there in the cross current operation. How to balance in each stage? What happens? The previous raffinate will fall, will be a feed for the next stage. That's the statement. In each stage, for each stage, the feed is nothing but a raffinate from the previous stage. For example, initially the fresh feed is giving as an input for the first stage of a multi-current multi-stage operation. Then for the next stage, the raffinate, the extract stream, which is there, which has been given by the first stage, is falling as a feed stream for the next stage. And similarly, the extract stream from the second stage is giving as a feed stream for the third stage. And similarly, for the npth stage or a last stage, the np minus 1th stage extract has been given as a feed for this np stage. In this, each and every stage, the raffinate or a solvent stream will be a different one. Okay, a different, or usually they will be a same stream. They are supplying as the same stream, but different. Say quantities are same, but the solvent will be the same. Quantities are different, but solvent will be same, like this. So how to balance each stage? We are going to see that one. So here, consider this one. So this is stage one, then this is stage two, or we can say just break it down, and final stage has been reached, NP. So NPth stage. So first, the notation scheme which we have applied for the single stage is same here. So first we are giving some feed here with a mole fraction, with a mass fraction of this solute is YF, and the inert mass ratio will be NF here. Then this is going, and another stream is adding on the first stage, which is a solvent stage, which we are denoting with R naught. R naught is going to affect, since this is the first stage, R naught 1. Then the mole fraction of C or a solute inside this rate we are denoting with X naught, and for the accountability of this B we are taking this N naught. Then this one is going inside. Then two streams are leaving. One is a clear stream. The clear stream we are denoting R1. The solute is X1. Composition of solute is X1, and this we are denoting with NR. So the notation scheme is same. F is equal to A plus B, A plus C. YF is equal to C by A plus C. NF is equal to B by A plus C. Then R naught 1 is equal to A plus C. Then X naught 1 is equal to C by A plus C. N naught is equal to B by A plus C. The same one is going to apply. Then another stream is coming out from the stage 1, is going as a feed for the next stage. This is because of connectivity, we are defining this as a multi-stage cross current operation, because they are moving in a cross current fashion. Then this is a extract stream we are denoting, or a inert solid stream. So we are indicating, since this is coming from first stage, this is E1. E1 is equal to A plus C. Then the next one is this one Y. So Y1 is for mass fraction. And N1 is mole mass ratio of inert solids. Then this is going as an input to the stage 2. Then similarly, one more fresh solid is coming to affect this leaching operation. So which is we are denoting with R naught to second stage. Then this is X naught on the second stage. Then N naught, which is on the second stage. Then the clear solution product is coming from the stage 2, which we are denoting with R2, X2, then N2. Then this is going to the stage 3. Okay, and there may be n stages in between this and second stage. So we are not going to consider that one. But this output is here, from output is E2, Y2, N2. the output from the NP minus 1th stage. Okay, the previous stage of NP stage is coming as the input for this one. So whatever the previous stage is, this one
Sir, your voice is breaking, sir.
Sir,
Your
your
voice
voice
is
is
your voice is
breaking, sir.
breaking, and this cursor also moving. Cursor also is there is lag, sir.
Okay. Wi-Fi. Okay, sorry. I have connected through mobile. Okay, is it okay now, Ravi?
Yes, sir.
Hello.
Yes, sir.
Okay. Okay. Can I explain from the starting onwards?
No need, sir.
Everybody same.
Yes, sir.
Means I explain from
Sir,
the starting, or just I will continue from here.
Continue,
continuous.
sir.
Continue. Okay. So the feed from the feed is coming for each stage from the previous stage. So this is NP. The total stage is NP. So the previous stage for this NP is ENP minus one. So minus one stage it is coming. So NNP up to the NNP it is coming. Then a fresh solvent is entering on this stage two. So this is R naught NP. Then with a composition of this composition of this solute is X naught NP. Then the composition or a mole ratio of this inert solid on this stage is N naught NP. So this is a notation scheme, just varying. Then two outputs are also coming from the final stage also. One is a clear solution stage, which we can indicate with raffinate on from NP stage. Then with a composition of a solute on the NP stage is XNP. Then with a insoluble solids on this stage is NNP. Then here one more stream is coming, which is a inert solid stream with a composition with a weight as a ENP. Then with a solute as YNP. Then with a inert solids as NP. So this is the notation scheme which is going to affect. Okay, this notation scheme is clear for everybody.
Yes, sir.
Yeah. For stage one, for example, for stage one, for single stage, we already derived that one. Once again, I'm going to apply this one. So see the overall balance. So overall means A plus C. So overall solution balance means A plus C. So here the notation scheme is F is equal to A plus C. Then R is equal to A plus C. E is equal to A plus C. This R1 is equal to A plus C. So that one only we are going to consider here. So two inputs are there. F plus R naught 1 is equal to two outputs are there. That two inputs are equal to two outputs. So this is E1 plus R1. This is for stage 1. Then this we have kept equal to some mixed stage or M1 or equilibrium stage M1. Then the solute balance, okay, solute or oil balance we can say. Solute balance. Whenever I am saying solute means the first thing which has to be strike up on your mind is C balance we can say in terms of our notation. So C is F into YF plus R naught 1 into X naught 1 is equal to E1 into Y1 plus R1 into X1 is equal to some mixed stream Ym1 into M1. So this one. So for the stage 1, this is for stage 1. Similarly, for stage 2, we can consider stage 2. For stage 2 is input is this one. The output of this stage 1 is going as an input to the stage 2. So we can say E1 overall balance E1 plus R naught 2, which is there in the upside. So R naught 2 is equal to two outputs, which is E2 plus R2 is equal to, here this is stage 2, we can say some mixed stream, which is M2. Then similarly for the solute balance means for C it is E1 into Y1 plus R naught 2 into X naught 2 is equal to E2 into Y2 plus R2 into X2 is equal to some, this one we can say Y M2 into M2. So this is for stage 2. So similarly, previously we have derived for ym1. So this is ym2 is equal to, we can equate this one and this one we can equate. So this is ey1 plus r naught 2 x naught 2 divided by m2. This m2 we can write this one or this one we can write. Similarly here also this also we can write f yf plus r naught 1 x naught is equal to this one divided by m1 is equal to ym1. This m1 is equal to this one or this one we can input. So this one once again I'm writing this one ym1 is equal to f into yf plus r naught 1 into x naught 1 divided by m1. This m1 we can substitute this one or this one. The same criteria for nth stage. So we will see for the last stage how it is going to affect the formula. So if you apply for the last stage, it is more than enough. So instead of NP, you can substitute 1 or 2 or something, whatever the stage it may be. So for nth stage, I am writing. So for nth stage. So input for this nth stage is one input is this one. So for overall balance, we are going to take only ENP from the previous stage, which is -1 plus this one is also one input. So this is R naught into NP is equal to two outputs are there. One is ENP for the overall solution balance, ENP plus this one RNP. So this is going to equal this M on the stage NP. So instead of this NP, you can write 2, 3, 4 for the each stage. I'm just generalizing this equation. So this NP minus 1. So if this NP is some 10th stage means, so this is coming from 9th stage. NP minus 1. NP is 10 minus 1. So that is 9 like that. So for the solute balance, it is E NP minus 1 into YNP minus 1 plus R naught NP into X naught NP. This is X naught NP is equal to ENP into, for the solute it is YNP plus here this one RNP into, for the solute it is XNP. This is whole equation is equal to some YMNP into MNNP. MNP. So this one. So now we can generalize this equation. YMNP is equal to this one is equal to this one ENP minus 1 into YNP minus 1 plus R naught NP into X naught NP divided by this one MNP. This MNP we can take from this one. We can write according to the given data from the problem. We can take this one equation or this one. We can equate this MNP. So this is the generalized equation. So these equations are going to come into effect. So out of this one, so one more equation we can write. So since we already know this one, E1 is equal to B by N1. So why it is E1 is equal to B by N1? So B is equal to B units, then N1 formula is B by A plus C. So B will be cancelled. It is going to be only A plus C. So because of this, E1 is equal to B1, B divided by N1, since B is going to stay same in overall operation. It is not at all participating in the leaching operation. Then here E2 is equal to B by N2. Then similarly for the nth stage, it is ENP is equal to, so here it is ENP is equal to B by NNP. So these formulas only you have to remember. These are all the material balance formulas. Now how we can estimate the using the graphical method, how we can estimate the unknown parameters. If you understand this graphical this material balance equations, you can just say yes, then I will continue. If you have any doubt, just ask me.
No doubt, sir.
Okay, then I am continuing the same one. How to estimate the number of plates, we can say number of stages, we can say, or unknown parameters R1 and R3 is there. How we can estimate if they are giving this many stages, means we can using the stages we can estimate R1, R2, R3, R4, like this you can estimate. But when they are not giving stages, means from this data only they have to provide R1 or E1, R or E something they have to provide, otherwise they have to provide n number of stages, how many stages are there. So the graphical procedure involves same as the previous single stage operation, with a small twist is there here. So here the first graph you have to draw is this one, n versus xy. So you're drawing like this. Then the same graph in the bottom side once again with the same x-axis you have to take. Need not to be same, this y-axis need not to be same, but x-axis has to be same for the two graphs. Okay, then this is going to be y and this is x. So when you draw this one, the first one, since this is a distribution curve or we can say equilibrium curve, this is diagonal line or 45 degrees diagonal line we can say. Then a curve x versus y curve, it is coming like this. So this will be x versus y. Then after drawing this one n versus xy, first you have to draw n versus y. So this is going to come like this in the previous case, as like the previous case. So this is n versus y. Then for usually for yours limited problems, this will be n versus x only, where there is no functionality between this n and x. So because of this not a function of x, n is not a function of x, so n is not at all dependent on this x. So this x-axis is falling as your n versus x for maximum cases. Then in the previous case, whatever we have seen in the single stages, after drawing these two graphs simultaneously, you have to first locate your point f. So the coordinates for this f point is yf and nf. So these are two coordinates from which you can estimate, you can just find out where your point f is lying. Then next point you have to find out is r naught. R naught coordinates is x naught comma n naught. Usually this n naught will be 0 because x is not n is not at all a function of x. So because of this, this point is always going to lie very near to 0, that too on the n is equal to 0 line only, on the x-axis only. So after drawing these points, what you do, just draw a straight line connecting r naught into r naught f. You have to connect straight line with a straight line. After connecting with a straight line, the first thing you have to do is locate the other point, which is a mixed point m1. M1 coordinates are ym1 comma nm1. Estimating through the material balance formula, these 2 points can be estimated, and that 2 points will usually fall on this straight line. Somewhere on this straight line it will fall. So that will, for example, consider this as a m1. This is M1. Now the next step is draw a tie line. So for the clue, the best clue for the tie line drawing is, so first just assume some value of x. So if your value of x is here, you are assuming, then you have to project this value of x until the equilibrium curve. Then after touching the equilibrium curve, once again a horizontal line you have to project, this point has to project until the diagonal, 45 degrees diagonal. Then as soon as if you reach this one, so like this, you have to project this until n versus y graph. Then if the points are coming like this, okay, that if this m is falling on this point, your guess is correct. Otherwise, your guess is totally wrong guess. You have to change your x value. Okay, otherwise you have to change your x value. So now if your guess is this one, so x up to projected up to the equilibrium curve or a distribution curve, then it has to be projected until the diagonal, then it has this point has to be projected on some n versus y curve, then you have to just connect these 2 points, then if your m1 is falling on this point, if that tie line is correct. So this is stage 1. Okay, then after this one, the criteria for this cross current is whatever the point here the tie line is where it is touching for n versus y is nothing but this is e1, and wherever this tie line is touching on the x axis, this is called r1. This is r1 value, this is x1 value. So r1 value is not direct r1 value, these are the coordinate values. R1 is equal to some x1 comma some n1. This is here also e1 means just a denotation point, that is notation, that is, but with a usual two coordinates because this is a graph, two-dimensional graph. So e1 is equal to some y1 comma n1. This is nr1. Okay, like this these 2 points will be there. Usually this nr1 will be usually 0, this one only. Then after drawing this point for the next stage operation, so whatever the even point you got in the previous stage, this has to be connected with this point R naught. So with a straight line, you have to connect this R naught and E1. So R naught E1 has to be straight line. You have to draw the straight line on this equation. Then M2 point, you have to locate M2 point. M2 point will be falling at the coordinate system ym2 comma nm2. You have to estimate for the using the material balance for the stage 2. Then that will be falling on this line now. So this will be m2. Similarly, same one you have to draw some tie line. So tie line you can draw using some guess value which is projected until the equilibrium or a distribution curve, then that will be projected until the diagonal line, then these 2 points has to be joined. If that is joining with that m2 is coming on that line or a tie line, that tie line is correct. So this is called stage 2. So similarly, once again, this is called E2 and this point is called R2. Then once again, for the next procedure, this E2 has to be joined with R0. Then after joining with R0, what you have to do? You have to once again just do this one M3. Locate your point M3. M3 is for stage 3. YM3 comma NM3. So using these coordinates, you have to locate this M3 point. After this M3, the same one, you have to draw the tie line. The tie line clue is first you have to guess your value of X, then it is projected up to the distribution curve, then once again up to the diagonal line, then once again up to the N versus Y axis. Then this is called stage 3. So like this, you can draw number of stages. If number of stages is unknown, they have to provide this E1, R1, E1, E2, E3 and R1 value. Otherwise, they have to provide number of stages value. Then you have to estimate at each stage what is the value of E1 and R1, E2 and R2, E3 and R3. Like this, you have to estimate. Is this okay?
Yes, sir. Let's
Yeah.
do some tomorrow, sir. Then it
Yeah,
will be
one
clear.
problem we will do based on this one. One problem is there with me from your old question paper only. I have taken that one. We'll do tomorrow.
Okay. Yes, sir. Then it will be
Okay.
clear, sir.
Yes, yes. Yeah. Okay. Okay, for everybody it is okay. I'm just clueless how you are grasping this one. In the physical class itself, it is explaining these problems are very, very difficult for me. But I don't know how you are grasping that one. Somebody, at least three, four people I want, somebody is catching this point, or once again I have to explain something, you just have to tell me. Only two people are responding, only Pavani and Ravi only. Vamsadhara, 32, roll number 32.
Yes, sir. Yes, sir.
Yeah, do you understand this one problem and this material balance as well as graphical procedure?
Yeah, yes, sir. I should watch a video once for graphical representation. So
Okay,
what
okay.
confused
Just
me. Yeah.
please, my request is just watch once again the
Yeah.
videos.
Okay, sir.
So these problems are very difficult because simultaneously we have to move with two graphs, not a single graph. So first single graph coordinate system is itself is very difficult, but with the two graphs simultaneously we have to move means somewhat we have to be very precious. Your pencil needs to be your needle of your pencil needs to be very sharp also, because when single small point variation in the graph itself, it will leads to a very major errors. So if you observe a major error means your calculation percentage recovery or percentage oil left inside that one is going to very much affect. So just watch once again the videos. In the next class, before next class, I will ask some questions. Then I will come to know whether you are understanding or not. Okay, now I am just clueless.